Hello everyone, welcome back again. My name is Jesse, and then in today's wonderful tutorial, we're talking about how to do gender classification, right, of names. So that is how to predict or detect the gender of an individual given their names. So we already know that most feminine names have A and then E as their ending. So we'll be using that idea to create or to train our machine learning algorithm to be able to detect and predict the gender given the name only. So first of all, you'll be using our EDA package as pandas and then NumPy, and then because we'll be working with names, we have to extract features from the text, right, the names. So we're using count vectorizer and then dict vectorizer. We can also use TF-ID, but it's preferable that we use these two, right? Okay, so now let's move on again to loading our dataset. So I have three datasets. You have this universal name, which is about 25 megabytes, and then this one is about unified versions of this. So we'll be using them to predict our name. So let's use the other name dataset instead of using the universal. Okay, perfect. So now let's check it and see. We are having some names like this: Mary, Anna, Emma. These are all English names. So that is the dataset you are using now, right? Okay, so first of all, you can check for the size of it, and then it's about 28,575, which is quite huge. So let's try and see whether our data is clean, right? So that we have to work with it. So by doing that, you check for the columns. So you have index, name, sex, they are all the same case. Okay, you check for the types, and then they are integers. Of course, index should be an integer, but because we'll be working with, because most machine learning algorithms deals with numerical data, right? So we have to convert this sex and name into numerical data so that you'll be able to work with it. So first of all, let's check on the presence of missing values. If you check for missing values, there is no missing value, which is nice. And let's check for the number of females in our data. We have about 18,000, which is plenty, and then for males it's about 10,000. Okay, now let me equate to df_name, and then I'll be replacing all my females as 0 and then all my males as 1, right? Because we want to convert them into numerical data. So when I do it like this, now perfect. So if I check for the unique, it's going to give us only 2. So we have only 0 and then 1. So 0 for females and 1 for males. So let's check for the types again. See that the sex has changed to integer. So now we can work with that. Now the next thing is we are supposed to work with the names. So how do we work with the names? How do we convert them into numerical data to be able to work with them? So we're going to extract features from it, right? So I'm equating it as S features, and then after that we'll be using count vectorizer. You initialize count vectorizer, and then you're going to fit and then transform the S features, which is the names, with our count vectorizer to form vectors, right, to extract features from it. So now we can see the features that has extracted and how it has been. So it has given us all these several names, which is quite plenty. Okay, after that we will try and split our data into training dataset and then test dataset using from sklearn model selection. And then after that, okay, let's work again. So after that will be the S is for the features which we got from here, which I have transformed into vectors already, and then the labels, which is the sex, which is actually the label, the outcome. We want to predict the gender, so that is going to be the labels or the outcome. So after that, you're going to train split our data set based on this random 42, and then nice. Now, so we'll be using a naive based classifier, which is very useful when you're working with tests. So we're trying to initialize this, this algorithm or the classifier, and I'm going to fit our S train, which is for our features, and then Y train, which is for our target or our label, together, and then I'm going to check the score for the test. Then there is about 63.9, which is not that bad, which is almost more than half percent, more than half, 50%, which is okay. But we can work with a different algorithm, so which will be doing that to be able to check the accuracy of that model, right? So this is the accuracy of our model, 63. Now let's do it again, the same thing for our training dataset itself. Let's do it for our training dataset and see what we're going to get, right? Instead of making it S train, we're going to make it as S train and then Y S train and now Y train, right? and then it's about 100%. Wow, which is so good. So it is most perfect, right? Which is dicey anyway. Okay, so let's move on again and use it, the model that you have created now, to predict something. So to predict, first of all, let's see how to work with the to extract features from a value. So we're using CV, which is a count vectorizer, and we have a name Mary. Then you're going to transform the data, right, and then convert it to arrays. So that is the purpose of this, to arrays. So if I do it again with this vec, if I check the vec, you realize that this vec is going to give us some numbers, right? So that is the name Mary has been converted into vectors and have been transformed, and then we are seeing it as an array. Perfect. Now let's predict it to see whether it's going to be a male or a female. Everybody knows that Mary is a female, so let's see whether it's going to give us a female. Perfect. So now our classifier is perfect, it's accurate that Mary is a female, so Mary was 0. So let's try again for a name like Mark, which is almost similar. It's Mary, then Mark, which is just one letter away different, right? To see whether it will be able to detect. So we do the same procedure. Then when we try it again, 1, perfect, that is a male. So although Mark and Mary are just almost the same words, but the last ending of Mary is Y and the last ending of Mark is K, it was able to predict that Mark is a male. So let's use a Russian name, right? Not an English name. So we have Natasha, and remember that most female names have NA at the back, right? As have A at the back. So Hannah, Anna, Natasha. So the same way in Russia, most of their feminine names ends with A. So when we try it, and then let's check it again. Perfect, it's a female, right? So you have a sample data random names of Nefertiti, which is an African name, Nasha, Ama, which is an African, Ayon, Nigerian, Xavier, Oveta, Ocean, Tatiana, Zia, Joseph, Zia, Ling. These are Chinese names. You're going to see when we mixed all these names, whether to be able to predict it well for us, which is going to be interesting. So now let's check and see. Okay, so Nefertiti is a female, Nasha is female, Ama is female, Ayo can also be female. Wow. Xavier is a male, Oveta is a female, Tatiana female, Zia, I don't know how to pronounce it, but it's seen it as female. Joseph is a female. Wow, Joseph is not supposed to be a female. Anyway, that is some of the errors you may have. So now let's write a function which will automatically do it for us. So that's the function we are creating. So we pass in our value, we will transform it, convert to arrays, transform it into vectors, convert to arrays, and then predict, right? So it's going to print for us. So let me put a name like Martha, and then Martha is female. Perfect. So now the procedure is that we created. So that is how to do it. Perfect. Now let's work again with something different and use the same thing. These are African names: Ya, Yao, Femi, Masha. So we realize that Ya is female. Perfect. Yao is female, is male, and then Femi is for female, and Masha, which is a Russian name, is also a female. So it's actually predicting it perfectly. So let's use a custom feature, right? A custom function. Let's create our own custom function feature to be able to do that. So as we already learned that most female names have A or E. So like French names, E for feminine and then A for most of the names. So we'll be trying to convert every name that is passed as lower and then extract the first names and then the last name. That is most of them. But sometimes you can also have the last but 2 names also being A and the last but 3 names. So that is the purpose of this function. So let's pass in something like that. So the feature is going to np numpy of the vectorizer, vectorizing this, and then we are going to work it on Anna, Hannah, Peter, John. Let's add another name to it. What name can we add? A name that is, let's say, Vladimir, and then let's add the last name, which is going to be Muhammad, right? So that we don't leave everybody out. So perfect. So when you check it is perfectly working, vectorizing it for us perfectly. So now we can use the same thing that we did here on this, apply it on our actual name for the main data set that we had, right? So we are going to use this function that we have created to do our feature extraction. So we are doing it as df underscore s to differentiate it from the first one, and df underscore dfy for the sex. And we're going to use dict vectorizer. So we are going to form dictionaries from these things like Mary and John, or we can use a different name. So let's say something like Mark and then Johanna, right? I don't know, Johan. I don't know whether Johan is a female name. So let's make a name like Julia. Julia, yeah, let's use Julia. Okay. Let's use this and let's use something different because we are using Mark too much. So let's use Mike. No, it's Mike, right? Okay. So perfect. So we starting it as a corpus, which means the body. We will vectorize it, fit it, transform it, and then see how it's going to give to us. Let's transform it well. Now we can get the features of it. Perfect is giving us, well, using our feature that we created. So now in the same way, we are going to train and test, split our data set into train and then test data set. And then when you do that, we are going to get these values, which is plenty. You see that it's working actually. What we did, our function is working within it. And then let's work with the fit transform, which I think we have already initialized. So we pass it through it. Take some time. Then perfect. So it's having sparse matrix, which is perfect. Now let's build our model using a different classifier, not the naive base, right? You're using a decision tree classifier. So since you are using you import it from sklearn.tree because it's a tree format of analysis, right? Decision tree. So random forest decision tree and all those stuff. So we'll be storing it as the CLF and decision tree classifier, and then we will be transforming our data that which we use our own custom function to extract the features, to transform it, and to fit and form a relation between our features, right, which has been transformed, and our labels, right, which is the DFY tree. So after that, it will take some time. Okay, so now it has finished. Perfect, it took some time anyway. So we'll be trying to use our classifier that we have created, our decision tree classifier, to do the predictions again. So we'll be going through the same process. We're going to transform the name Alice, pass it with a feature which we created a feature function, and then we try it and see. And then we're going to commit it to arrays. It's working well. So now let's predict it. As we know, 1 is for male and 0 is for female. So let's try it and see. Perfect, 1. So Alex is actually a male. So let's use the same thing on something different. And you see that it's printed it as male. Perfect. So let's use a local Nigerian name, right? An African name like Chioma. So when we do it like that, we are passing it as Chioma, transforming it, then converting to arrays, then using it to predict and see what it's going to give to us. Chioma is feminine, so it's actually perfect. So our model is a good model. So we can create a function like we did for the previous one, and then apply it on this name too. We had Vladimir, so let's change it from Vladimir to Vitalik, right? The founder of Ethereum, Vitalik. And then let's use a different name. Instead of Mohammed, let's use a local name like which name do you use? Jackie Chan, right? Chan. So Jack Chan. I don't know whether Chan is a first name. Okay, now let's work on this. So we're going to look through it and apply a function to it. Perfect. So the Alex and Alex are male and female. Perfect. Chioma is female. Perfect. Vitalik is Vitalik. Wow, I don't know. Clarissa is female and then Chan is male. So perfect. Jackie Chan is male. So our model is actually working very well. Okay, so that is what we have done. So let's try and check the accuracy of this model that you are working with, right? Take some time. What is, wow, 0.99, which is very high. And for the test, it's going to give us 80 something, which is okay. So our model is very good. So now let's try and save our model because we're using it for the next session. So we'll be saving it with from SQL export externals, and then we'll be saving it as the decision tree model, right? Because that is what we'll be using it for. And then I'm going to save it as DCLF, which remember, job lib.dump, that's how to save it. And then the decision tree model, I'm going to close it, so it has been saved perfectly here, right? Nice, so that we can use it for our analysis. You can also use Pickle if you want to do it, and it's still going to work perfectly for us. So now let's save our multinomial, which was this naive base, and then we're going to write it, we're going to close it. Okay, so thank you for watching this long tutorial. If you have any questions or contribution, you can just put inside the comment section so that everybody can benefit. And please don't forget to subscribe. Stay blessed. The code will be in the description below. Thank you.